Okay, let's dive right in. Today, we're going to talk about a hidden standard that, honestly, makes so much of our digital world work. Think of it as a universal blueprint that lets developers build these complex software worlds in one place and then share them with, well, pretty much anyone, anywhere.
I mean, really, think about that for a second. How do you take an entire digital world, we're talking an application, its operating system, all its data, every little setting, and move it from, say, your laptop to some massive cloud server, or even to a totally different company's system? For the longest time, this was just a complete and utter mess. And yeah, nightmare is the right word. You see, every system spoke its own language. Trying to move a virtual machine was like trying to build IKEA furniture with instructions from a Lego set. It was frustrating, super inefficient, and a lot of the time, it just plain didn't work. But then, a standardized solution came along, a single, universal set of instructions that everyone could finally agree on. And that blueprint, it has a name, OVF. It stands for the Open Virtualization Format. This right here is the hero of our story today. It's the standard that brought some much-needed order to the chaos of moving virtual machines around. So what does all that jargon actually mean? Well, it really just comes down to two big ideas: platform independent and standardized. An OVF package isn't locked into one company's ecosystem, like VMware or VirtualBox. Nope. Instead, it's like an open language that all the major players have agreed to understand. It's just like how a real blueprint lets you build the same house anywhere in the world. OVF lets a virtual machine run anywhere. All right, so if OVF is the blueprint, what's actually written on it? What are the individual parts that make it so powerful and universal? Let's peel back the layers a bit and take a look inside the package. Okay, this is where that blueprint analogy gets really good. First, you've got the OVF file itself. That's the master plan. It's basically a text file that lays out the virtual machine's architecture, how much CPU and RAM it needs, its network settings, all that good stuff. Then you have the disk images, like VMDK files. These are the actual digital building materials. They hold the operating system, the applications, all the data. And to make sure nothing gets lost or messed up along the way, there's the MF or manifest file. It acts as a parts checklist using these digital fingerprints to verify everything's there. You can even have a certificate file, which is kind of like getting your blueprints officially notarized. It's an optional stamp of authenticity. So we've seen what an OVF package is made of. But the real story here isn't about the file types, right? It's about what this standard actually unlocks. Why does having this universal blueprint matter so much in the real world? This is where OVF goes from being just a neat technical detail to an absolute game changer. So what's the big payoff for all this work on standardization? What can developers and IT pros do now that was so hard to do before? It really boils down to three key things. First, pure portability. You're no longer locked into one vendor's system. You can build a virtual machine on one platform and know with confidence that you can deploy it on another. Second, standardization. Because it's an open standard, you get this healthy ecosystem where all sorts of different tools and platforms can talk to each other. And third, and this one is huge, is automation. A software company can package up an entire complex application, like a database server, into an OVF. So instead of a customer having to follow a 50-step installation manual, they just import the OVF and boom, it's running. Think about how much time and how many errors that saves. Now, before we wrap this up, we got to clear up one common point of confusion. If you've ever worked in this space, you have definitely seen another very similar acronym, OVA. So what in the world is the difference between an OVF and an OVA? It's actually incredibly simple, and it all just comes down to packaging. The best way to think about it is this. Are you carrying around a folder full of separate blueprint documents? Or is everything rolled up neatly into one of those convenient cardboard tubes? See, an OVF is that folder of individual files. This is super useful when a developer might need to go in and tweak just one piece, like that master instruction file, without having to repackage the whole thing. An OVA, on the other hand, is the tube. It takes all those separate files, the OVF, the VMDK, everything, and bundles them into a single compressed archive file. This makes it way easier to download and share. You're just sending one file instead of a whole folder. But here's the key. They contain the exact same information, they're just packaged differently for different situations. So the really important thing to take away from all of this is that OVF isn't just some boring technical spec. It really represents a whole philosophy. It's this idea that your digital creations shouldn't be trapped inside one company's proprietary prison. It's about creating a common language that gives us freedom, flexibility, and collaboration across the entire digital world.
And that leaves us with a really fascinating question to chew on. When you remove all the friction of moving these entire digital worlds from one place to another, when any application can be packaged up and deployed anywhere with just a single click, what does that make possible? What gets built next?